So there are three different numbering systems, and we're going to do conversions between the three numbering systems. So the first thing that we're going to do is we're going to convert to decimal. So we're going to go from binary to decimal and from hex to decimal. Then we're going to do conversions from decimal. And then finally we're going to talk about the two other types of conversions between binary and hex. So these are the 6 types of conversions that we're going to be doing. So if there was a single word that I would use to describe the conversion to decimal, it would be positional value. We're going to take into account each one of the individual positional values as I try to take any numbering system, not just binary or hex, and convert it into decimal. So let's give that a try. First type of conversion that we're going to do is from binary to decimal. So let's start with a binary number, 10111100. This is a binary number, so I'll put the subscript on it. If you don't mind, I'm going to rewrite it a little bit farther down because I would like to give myself a little bit of room because I know each one of the individual digits has a positional value. And so if the conversion to decimal is all about finding positional values, I'm going to give myself a little bit of room, and then I'm going to write the positional value below it. Once I have the positional values written down, I'm going to calculate each one of those. So I have all of the positional values, and then I'm going to multiply the positional value by the value that happens to be sitting in that place. Once I have those values written down, I'm going to add all of those products together, and let's see what we can get. So this is going to be 128 plus, well, 64 times 0 is 0, plus 32 plus 16 plus 8 plus 4. And if I did my math right, ultimately I should have 188. So we're going to see that the binary number 10111100 is equivalent to a decimal 188. So let's do another one. Convert binary to decimal. So the number that we're going to start with this time is 1010. If you don't mind, I'm going to put a hint of a space between groups of 4 to try and make it more readable. Then each one of them will have a positional value. Then I'm going to find out what those positional values mean. The first one is 2 raised to the power of 0. Anything to the power of 0 is 1. Now I know what the positional values are. The next thing that I'm going to do is I'm going to multiply by the value that is sitting in that place. So the first one will be 1 times 0, 2 times 0. And then I'm going to add them all together. So this should be 128 plus 0 plus 32 plus 0 plus 8 and if I do my math right, this one should be 172. So the binary number 10101100 should be equivalent to a decimal 172. So I'll have you try this one on your own. The binary number 11111100. I'm going to have you convert this binary number into decimal and see what you get. If your answer was a decimal 242, then you did it correctly. So the next one we're going to do is hexadecimal to decimal. So let's start with a hexadecimal number. I'm going to put the subscript on it to indicate the fact that it is a hexadecimal, and I'm going to find the positional value for each one of them. Once I have the positional values, I'm going to figure out what they each are. Anything raised to the power of 0 is 1, and then I'm going to take the positional value and I'm going to multiply it by the value that is sitting there. This would be 1 times 5. This is going to be 16 times 1, and this is going to be 256 times, well, the letter A in my decimal brain is actually a decimal 10. So I'll multiply it by a decimal 10, and then I'll add each one of those products together. This will give me 2560 plus 16 plus 5, which if I did my math right, should be 258. So a hexadecimal A15 is equivalent to a decimal 2581. So let's do one more. This time we're going to do something a little bit larger. How about if we try F3B8? I'm going to write them separated a little bit just because I know that I'm going to need to find positional values. I'm just going to give myself a little bit of room. So I'm going to find the positional value of each one. Once I have each of the positional values, I'm going to multiply the positional value by the value that is sitting there. We'll have 1 times 8, 16 times b, but my decimal brain would have to equate a decimal b to an 11 in order to be able to multiply it by the positional value. This is going to be 256 times 3, and then I'm going to have 4096. Once again, my decimal brain would tell me that an F is actually a 15. So I'm going to take the 4096 and I'm going to multiply it by 15. And then I'm going to add each one of these products together. And we are going to get 61,440 plus 768 plus 176 plus 8. And if I did my math correct, the answer should be 62,392. That means that the hexadecimal number F3B8 is equivalent to 62,392. All right, so I'm going to have you try this one and tell me what you come up with. Take the hexadecimal number CD19 and convert it into a decimal number and tell me what you come up with. If your answer is 52505, then you have the right answer.